with a problem like 21 on page 718. Given that sine alpha is 4/5 and cosine beta, it was A and B, I'm sorry. So anyway, so I changed it to alpha and beta, that's fine. Equals 1/3. With A and B both in the interval 0 pi over 2, which means the first quadrant, find sine A minus B. So the question is asking us to find sine alpha minus beta, and also cosine alpha plus beta. I think we should choose one or the other. You choose whichever you prefer. Just choose sine. I don't want to do sine. Very good. Because cosine will be very similar, right? Once we determine everything that we need for sine, so you can determine cosine. So we know the formula or the identity. Sine alpha minus beta is sine alpha cosine beta minus sine beta cosine alpha. We're only given sine alpha, which is 4/5, and cosine beta, which is 1/3. So I'm going to put them in here. So this is 4/5, and this is 1/3. I do not have sine. I do not have sine beta, and I do not have cosine alpha. But as we know, we can always go back to that right triangle with an acute angle alpha, whose sine is 4/5. It must be 4/5. We can always determine the leg, 25 squared, 25 minus 16, so it's 9. The square root of 9 is 3. We know that these are called Pythagorean numbers, 3, 4, and 5, because 3 squared plus 4 squared equals 5 squared. So now we can determine cosine alpha. Can anyone give us cosine alpha from here? Very good. And the same way, we created a right triangle with an acute angle beta, whose cosine is 1/3. 1/3. We get the square root here of 9 minus 1, which is the square root of 8. So this leg is the square root of 8, which is 2 the square root of 2. So now, knowing this, we can identify sine beta. Can anyone give us sine beta? Over? Very good, awesome. Excellent. So 2 the square root of 2 divided by 3. Now we have all pieces we need. We just have to put them together. So therefore, sine alpha minus beta equals 4/5 times 1/3 minus 2 the square root of 2 over 3 times 3/5. I do not recommend you simplify here because the least common denominator will definitely be 15. You need that. So this is 4 minus 6 the square root of 2. So with the given information, we were able to determine sine alpha minus beta, and also using the identity, sine of a difference of angles. Okay. I would like us to determine any of these numbers, sine 75, sine blah, 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 and I would like us to choose more identities to prove, and then we move on to the next section. So we want to choose any of the angles, which we don't know. I don't know what sine 195 is. I have to work on it. I don't know what sine 75 is. I have no idea. I don't know what tangent of negative 15 degrees is. No idea. Which one? The tangent? Yeah. Okay, perfect. And then we have to look at some identities. So here, we are not told that these are identities. It says, interesting, prove or disprove the statements. Here, this is not a tricky question. We are told these are identities, prove them. Okay? So let's choose one. So we already chose 46, so let's choose one from the identities. 51?
Yeah.
Very good. Awesome. Okay, so first we start with 46. Tangent of negative 15 degrees. First of all, I know tangent is an odd function or is not an odd function. It is odd. Excellent. I refuse to work with negative angles, so then this is negative tangent 15 degrees. So now I think of the three angles that I know everything about. I know 30, 45, and 60. Can I use any of these angles, maybe one or two or maybe three, to create 15 degrees? Very good. So this must be negative tangent 45 degrees minus 30 degrees. Make sure when you use those known angles, make sure the tangent is not undefined. Yeah, tangent is not undefined at 45 and is not undefined at 30.
Could you split that paper down?
Yes?
See if this is found?
So then we use the formula for tangent of alpha minus beta. So from here we have minus tangent 45 minus tangent 30 over 1 plus tangent 45 times tangent 30. Now you could say, I'm getting into trouble. You told me not to memorize tangent. True. But first of all, we know that tangent 45 is sine 45 or cosine 45, and that's the only angle for which both are the same. So we can never forget tangent 45 being correct? Because sine and cosine are the same. Perfect.
I don't understand how you got that. From that to this.
And you have to look at the formulas from last time. Yeah. So now the tangent of 30 degrees. So this is the very first angle, right? The smallest angle. Sine is 1/2, cosine is the square root of 3 over 2. And when you put them like this, it's not going to be a simplified form. Because you'll have to flip 2 over the square root of 3. Now for the bottom angle, which is 60 degrees, you'll have the square root of 3 over 2 over 1/2. And that will be always the square root of 3. So the tangent for the bottom angle is nice. The tangent for the top angle is a fraction. You don't have to memorize that, but you have to remember what we discussed. So let's write both. So for tangent 30 degrees, you know is the square root of 3 over 2 over 1/2. I meant to write the opposite, of course, 60 degrees. So the tangent for 30 degrees is 1/2 over the square root of 3 over 2. So now when you simplify this one, this is always nice is the square root of 3. But when you try to simplify this as 1/2 times 2 over the square root of 3, you will get the square root of 3 over 3. But you don't need to memorize this. You just need to create this ratio, and you get this for 60 degrees, which is not the case here. And you create this ratio, 1/2 over the square root of 3, and you immediately determine that that is the square root of 3 over 3. So then we write minus in front, and this is 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. Normally the answers have to be completely simplified and no radicals in the denominator. So I will find the least common denominator, we'll find the least common denominator, flip the denominator, and then rationalize. So there are a few more steps here. This is not good enough. So this is negative 3 minus the square root of 3 over 3 times 3 over 3 plus the square root of 3. So this is 3 plus the square root of 3 over 3, and I flipped it. And this is 3 minus the square root of 3 over 3. I'll simplify 3 with 3, but need to rationalize. It's a lot of work on something like this, so please be careful. So at this stage, I have 3 minus the square root of 3 over 3 plus the square root of 3, and I rationalize with this because I need the conjugate. So in order to rationalize denominators, and sometimes in calculus you will have to rationalize numerators, so keep that in mind. But most of the time we rationalize the denominator. So 3 plus the square root of 3 needs 3 minus the square root of 3, and we multiply, and then we have to multiply the top. And the top is a minus b squared, or you FOIL, which I prefer not. So the first term squared, minus 2 times the first times the second, plus the second term squared. And the denominator is 9 minus 3 because it's the formula a minus b, the identity, or the special product a minus b times a plus b. A squared minus b squared. Do not attempt to simplify in a sum. You have to combine like terms and factor. So this is negative, this will be 12 minus 6, the square root of 3, and this is 6. You either separate or factor. So this is negative 2 and plus the square root of 3. Look at how long it took us because we had so many different steps and we had to rationalize.
Wait, it shouldn't be negative.
Shouldn't it be?
2 minus square root of
Yeah. I distributed a negative 1, right?
Yeah, the negative has been added.
Oh, shoot. I missed that.
That's okay. That's okay.
Oh, there it is.
I thought. So the tangent of negative 15 degrees is this, and this is exact. So just punching in the graphing calculator and get a number, it's not going to work. So we're asked to come up with the exact number. Any questions? Any questions on any of these steps? Any questions? Okay, let's move on to that identity. I don't remember what you picked. Yes, we picked 51. Yes, I do remember now. 51 on 719. So cosine x plus h minus cosine x, everything divided by h. They say it equals cosine x times cosine h minus 1 over h minus sine x sine h over h. Very good pick. I've never seen anything similar in the previous pre-calc courses that I taught. Very good pick.
So it's like calculus.
I don't understand.
Say it again. Okay, so which part do you think we're going to start with? Should we start with the left-hand side? Should we start with the right-hand side? Yes, because the right-hand side appears to be more involving, appears to need more steps. The left-hand side for now is just a fraction. I don't know what to say about it yet. So let's start with the right-hand side. Perfect. So I see that these two have the same denominator. So when I subtract them, I will write only one denominator. And then I will have to distribute at the top. Cosine x, cosine h, minus cosine x. So cosine x, cosine h, minus cosine x. And assuming I copied it correctly, yes, the second one doesn't have, yep. So negative sine x, sine h.
Why do you have two minus signs right next to each other?
So one, you mean that?
Follow through
Yeah, just to tell you that something follows.
because it's underneath it, not next to it, so she's just.
There are not two negatives in there. I would have put parentheses or something. You don't have to do the first one or the second one. It's up to you. You choose. Okay, so now we see that cosine x, cosine h minus sine x, sine h. What can you tell me about that? It's one of the special identities, right? The identities that we looked at last time. Cosine alpha, cosine beta minus sine alpha, sine beta.
Oh, it's a sum of.
Sum of, very good. Cosine x plus h. Excellent. So this is cosine x plus h minus cosine x divided by h. There is no need to do anything else. I see that this is the same with the left-hand side.
Wait, did you say it was cosine x plus h because there's two negatives? So it made a
No, she said there's that second negative.
So when you expand
Oh,
cosine x plus h, you get cosine x,
Yeah,
cosine
okay.
h minus sine x, sine h.
I thought it was plus sign.
No, it's the cosine is twisted. If you have positive here, it's the difference of two terms. If you have negative in here, you have the sum of two terms. So it turns out that this was much easier than we ever expected. We only had one step just to change this into cosine x plus h, and that's it. Any questions on this? Any questions? Okay, so let's continue then with 9.3, double angle. Identities. We are way ahead because we already looked at, we needed to last time. So we remember the formulas or the identities sine A plus B as being sine A cosine B plus sine B cosine A. And now let's say these are the same. That's the double angle identity, sine of twice an angle. So what if A and B are the same? What should I write? What will the right-hand side be? Good. Sine A, cosine A plus sine A. Good. So then what is that? So they're identical. So then it's 2 sine A cosine A. The cosine twice A, we already have it from last time. Cosine twice A has 3 different options. It has cosine squared A minus sine squared A. It has 1 minus 2 sine squared A, or 2 cosine squared A minus 1. These come from this. And cosine twice A comes from the formula cosine A plus B. In the same way, we have tangent. And then we can practice this. Oops.
So,
Yes?
Because I see you have sine quantity A plus B. So if you're saying you had sine quantity A plus A, that's technically 2A. And therefore you would have.
If they are the same. If I have 30 plus 30.
Right, you just add those two.
So if is this A and this is A, then I have sine A, cosine A, sine A, cosine A. And both quantities are identical. Sine A, cosine A is the same. So then you add them up and combine like terms and you get 2. Is that okay? So the same for tangent. So we have 2 tangent A over 1 minus tangent squared A. Let me write the formula so you see where it's coming from. So we had tangent A plus B, which was 1 plus tangent A. I'm sorry. Tangent A, tangent B over 1 minus tangent A, tangent B. So tangent A plus tangent A is 2 tangent A. Tangent A times tangent A is tangent squared, and 1 is 1. Now, what is important here is to understand that we can write these identities in any situation. So let's go back to sine for a second. We said that sine twice A is 2 sine A cosine A. What if I want sine A? What will that equal to? And before you say anything, I just want to give you a hint. If this is twice A, this is A, and this is A. If this is 4A, then this is 2A, and this is 2A. But what if I want now sine A? What should I write? The 2 has to be in front. So what will be the relationship?
Sine A over 2.
Thank you. And cosine A over 2. So these four, yes, go ahead.
I think you're about to answer. Sorry.
No, I just wanted to say that these identities are kind of dynamic in the sense that they are not carved in stone for 2 times A. I can have anything. I can have 3A in there. So what will it be the formula for 3A? 2 sine.
3A.
Over 2.
Very good. Cosine 3A over 2. So, because I pointed out the fact that this is double angle and this is the angle. So whatever you have here, you have to divide by 2 to get that one. That's why it's called a double angle. And this is true for all of them. So, of course, if now I would like to determine, let's say, cosine 4A, what will you write? For example, cosine 4A, let's say we use the first formula. That would be cosine squared of, very good, minus sine squared 2A. So,
Oh. Can you do it in C?
any questions?
I get it. I I don't. Mine says-
So the hint was that this is a double angle and everything you say there is the angle. If I put 100 million here, I have to divide 100 million by 2.
Okay.
All the way, because it's a double angle. That's why the name. So if I want here 1,000, then this would be 1,000 over 2. If I want here 7, then this would be 7 over 2. Because that's the pattern, that's the identity. It's the double angle identities that results in, for example, for cosine, any of those three, cosine squared A minus sine squared A. Yes?
So if it was cosine 6A, it's be cosine squared 3A minus sine squared 3A.
It's a double angle identity.
Can you go back to the tangent ones?
Yes? Let's go back to the tangent.
You go up to 1.
The previous one?
Yeah, look at the tangent to it.
Tangent to A. So it's tangent A plus tangent A, which is to tangent A, and tangent A times tangent A, which is tangent squared. So 1 minus tangent squared. Is that okay? Caleb, is that okay? When I add tangent A to tangent A, I get 2 tangent A. An apple plus an apple is 2 apples. And then tangent A times tangent A will be tangent squared A.
There's not tangent.
But you were. That's because right there it's.
This is A and B. This is the formula, but now they are equal. Now they are equal.
Okay.
So tangent A times tangent A will be tangent squared A. Because they are the same angle.
Yeah, you just plug it in.
Is that okay?
Mhm.
Perfect. So let's look at a couple of, before we continue with half angle, I'd like to look at a couple of problems. See how this works, maybe with identities. Okay. We're asked to find sine 2x, cosine 2x. This is a typical type of problem. So we are on page 730. If sine x is 1/8 and x is in the first quadrant, find these. I would like us to choose a problem, but not with the first quadrant because everything is positive in the first quadrant. So let's look at another situation. So either cosine x in the third quadrant or tangent in the fourth quadrant.
Let's do number 7.
Number 7 is good. So for number 7, we are given that, so this is 7 on page 730, and we are told that cosine x is negative 1/2. Cosine x, negative 1/2, and x in the third quadrant. We have several options here because we know cosine 1/2. What angle has cosine 1/2? Let's suppose we don't know. Suppose we get 3/4. If we get 3/4, then we don't know what angle that is. So let's consider that we have no idea. Fine. So I need to find sine 2x first. In order to find sine 2x, I have to write the formula 2 sine x cosine x, in which I have cosine, which is negative 1/2. Here again, I have several options in order to find cosine. I know what cosine is going to be equal to, correct? Because if cosine, what sine would be equal to? If cosine is negative 1/2, sine negative the square root of 3 over 2, correct. Why negative? Because we're talking about an angle in the third quadrant. Excellent. So this obviously will be negative the square root of 3 over 2. If cosine is 1/2, then sine must be the square root of 3 over 2. If cosine is the square root of 3 over 2, then sine must be 1/2. So in this case, we determined sine twice x. So this is 2 the square root of 3 divided by 4, and we simplify, and it's the square root of 3 over 2.
So they give that cosine of x was negative 1/2.
It is in the problem 7, yes. That's given to us. And where the angle is. Good. So now we want to find cosine twice x. And because I'm given cosine, I would prefer to do this. 2 cosine squared x minus 1. So this is 2. I square cosine to get 1/4 minus 1. So this will be 1/2 minus 1, which is negative 1/2. I don't want to use the formula for tangent. Why? For tangent to twice x. Because I have sine and cosine. You can if you want to. But once I have sine 2x and cosine 2x, I'll say tangent to x will be the square root of 3 over 2 over negative 1/2, which is negative the square root of 3. And now I'm going to ask you this question. Which quadrant is twice x, the angle twice x in? Can anyone tell us where it is, in which quadrant is twice x? We know x is in the third quadrant, but where is twice x? How do I know it's the second? Yes, awesome. Oh. How do I know it's the second? Sine is positive and cosine is negative. Excellent. Great job. So then I will say 2x in the second quadrant because sine is positive and cosine is negative. Great job. Awesome. Any questions? Questions? Okay. Let's look at 11. In 11, we are given the following information. 11 on page 730. They're asking us to simplify 2 sine pi over 4 times 2 cosine pi over 4. Of course, I'm going to write 4 in front, and then I will replace these 2 by, or not. Let me write it one more time. Sine pi over 4 and cosine pi over 4. So now if you correctly identify what I'm getting at, you will say, oh, I know this equals what? Two sine A cosine A. What does that equal to? Sine 2A. Excellent. Sine of 2A, which is 2. This is sine pi over 2, which is how much?
1.
Very good. So then the answer is 2. And we use the double angle identity. Okay, let's continue with half angle. Identities. Okay, so let's go back to cosine twice A. Can anyone remind us what this equal to? I don't want the general one, I want the other two. So either 1 minus 2 sine squared A or 2 cosine squared A minus 1. So we know we have 3 possibilities for cosine twice A. Either 1 minus 2 sine squared A or 2 cosine squared A minus 1. Now, I would like to change this quantity into A. What will I change this quantity into? If I change this into A, what do I have to change this into? Excellent. So let's do that. Because we know that it's allowed and it's possible. It's the same thing. So then cosine A is 1 minus 2 sine squared A over 2. The same thing for the second one. Cosine A is 2 cosine squared A over 2 minus 1. From
Why
these,
do you have 3 possibilities for that one?
because we have cosine squared minus sine squared. The first one. This is what we did last time. Cosine twice a, cosine squared minus sine squared. If you replace in cosine a plus a, you get this. Cosine a plus a is cosine a times cosine a minus sine a times sine a, and we get this. Is that okay?
So I guess what they're doing is they're changing, I guess the cosine squared a minus sine squared a equals 1. So what you're doing is you're just substituting each one of those terms for the other.
So in cosine a plus a, I have cosine a times cosine a minus sine a times sine a, which is cosine squared a minus sine squared a. And that was the first one that you were asking about. But if I replace cosine squared by 1 minus sine squared, I get the second one. If I replace sine squared by 1 minus cosine squared, I get the third one. So they all come from here, from the sum. Okay, is that better? Yes? So then coming back, this is the first option that I just showed you. If you replace this, you get this. If you replace this, you get that. So these two are coming from here. Is that okay? Just replace this by 1 minus sine squared and you get this one. If you replace this one by 1 minus cosine squared, you get that one. Yes? Okay. So then we wrote those two options, not the generic one, but the one with only sine and the one with only cosine. Based on this, we replaced the double angle by a single angle, and then we had to replace this by a over 2. That's how the formula works. That's why we talked about this earlier, because I need this. I need this understanding for what follows. That's why I gave you those examples. So sine of twice a is 2 sine a cosine a. If you change this into a, then you have to change these correspondingly into a over 2. If you have 3a, then this is the double angle, so this must be half. If you have 4a, this must be half.
Can I take a picture of that real quick, because I didn't know where all that is.
But I'm going to post this,
That's okay.
right? Okay, so coming back to these two equations, we want now, because we're talking about the half angle, what do you think we're going to solve for in order to get the formula for the half angle? Say it again. Sine a over 2. That's what we're going to solve for, because we want the half angle identities. So this equation, so cosine a equals 1 minus 2 sine squared a over 2. I'm going to move this here and that over there. 2 sine squared a over 2 equals 1 minus cosine a. Therefore, sine squared a over 2 will be 1 minus cosine a over 2. So from the double angle, by simply replacing the double angle by angle and the corresponding by angle over 2, we determined the half angle identity, which normally we like to take the square root, but that is okay too for sine squared a over 2. And we get sine a over 2 equals plus or minus the square root of 1 minus cosine a over 2. If we repeat the same steps for cosine, what do you think we're going to get? Just a wild guess. What do you think cosine a over 2 will equal to? Identical, but plus. If this creates any confusion, I can go back and redo any of this part. Any piece of it. Is there any confusion with this? Should I go back to any of that?
So did you stop at sine a over 2?
We're talking about,
You don't want to go any further than that, or what you
we're
want to just
talking
leave
about the
separate?
half angle identities. Sine of half an angle. That's all we want. Sine of half an angle.
But I guess if you wanted to then solve for A, you would just take the arc sine
Yes,
of that.
yes. Of course. Yes. Any questions? What about tangent? Okay, so let's take a look at tangent. One formula for tangent A over 2 will be sine over cosine, right? So plus or minus the square root of 1 minus cosine A over 1 plus cosine A. That will be one option. And there are two other options. Either sine A over 1 plus cosine A or 1 minus cosine A over sine A. The first one I showed you where it's coming from because I have sine and cosine. The other two I did not. These are determined with multiplying by some conjugates to get those results. I will give you these two. You do not have to memorize these two. So if I put anything like that on the test, you will have those two. You will have the tangent A over 2 as being either this or this. So let's practice a little bit with the half angles. For the following exercises, find the exact value using half angle formulas. And then for the following exercises, find the exact values of sine x over 2 like we did a few minutes ago with double angle, cosine x over 2, tangent x over 2, without solving for x. Okay, so let's do that too. So let's choose any angle. I don't know, can we do sine pi over 8? Okay, so let's look at sine pi over 8. So this is problem 13. See how these formulas work. So we're asked to determine the exact value of sine pi over 8. If you punch it in the calculator, you're not going to get an exact number. So I'm thinking that maybe there is a way, since they are also mentioning using the half angles, maybe I can do this. Something over 2, that is pi over 8. And that something is, I'm hoping, something I know everything about. So what could that be? Exactly. Exactly, pi over 4. And since I know that this is in the first quadrant, I will have the square root of 1 minus cosine pi over 4 over 2. Where does this come from? From here. Sine of pi over 4 over 2 equals, in this case it's positive, the square root of 1 minus cosine pi over 4 divided by 2. I know what cosine pi over 4 is. Not nice, but it is the square root of 2 over 2. Everything over 2. I will find the least common denominator in the numerator. So this will be 2 minus the square root of 2 over 4. And that will be the square root of 2 minus the square root of 2 divided by 2. And this is exact. So it was 2 minus the square root of 2, and 2 times 2 was 4. I could not take the square root from the numerator, but I was able to take the square root from the denominator. Questions on this problem? Okay, so let's take a look at any of these. So let's choose one in which we're asked to find sine alpha over 2, or x over 2, sine cosine x over 2, and tangent x over 2. Which of these would you like to, which one? Okay, 21. If you don't want to pick, I will. So 21 on page 730. 730, 21. Yes. So x, sine x equals negative 12 over 13. And x is in the third quadrant. All we're doing is just practicing these identities. So here the question is asking us to find sine x over 2, cosine x over 2, and tangent x over 2. Now, the first step is we have to find where x over 2 is. Because I don't know, this is plus or minus the square root of 1 minus cosine x over 2. And this is plus or minus the square root of 1 plus cosine x over 2. And this will be the ratio of those. So if I don't know where x over 2 is, I don't know whether to put plus or minus. I cannot put plus or minus. It has to be one or the other. But look what happens now for the half angle. I know that x is in the third quadrant, which means not the endpoints, between pi and 3 pi over 2. That's the third quadrant. What do you think I'm going to do to all three sides in order to identify the quadrant for x over 2? What do you think we're going to have to do? Well, of course. So pi over 2 less than x over 2 less than 3 pi over 4. So now I know that x over 2 is in which quadrant? Very good, indeed. Second quadrant, somewhere between pi over 2 and pi. Very good. So therefore, I know that sine will be a positive number or a negative number. Excellent. I know cosine will be a positive number or a negative number. Very good. That's all I needed. So then sine x over 2 will be the square root of 1 minus cosine x divided by 2, which I don't have, by the way, but I will in a minute. And the other one, cosine x over 2, will be negative the square root of 1 plus cosine x over 2. I am given sine with the knowledge that x is in the third quadrant. What will be the sine of cosine then? For an angle in the third quadrant. Cosine will be? No, very good. And all I have to write is either you create the triangle, you determine the sine, or you say 1 minus this squared, 144 over 169. 169 minus 144 is 25, so 5 divided by 13. Or you can create a triangle, whatever works for you. I use the identity. I said if I'm given sine that is 12 over 13, I know cosine has to be negative, so negative the square root of 1 minus sine squared. And then 169 minus 144 is 25, the square root is 5, and the square root of 169 is 13. I have everything I need now to determine sine x over 2, because now I know that this is negative 5 over 13, and I know that this is negative 5 over 13. All I have to do is just plug them in, simplify as much as possible, and get the tangent. Any questions? Any questions so far, please, before we do that?
How you get
Yes?
144 over 169?
Okay, so cosine is negative the square root of 1 minus sine squared, and sine is given to us, 12 over 13.
Nice.
So I squared, I got 144 over 169, and then I took the square root. Connor, you had a question?
Yeah, how did we find out that it was in quadrant 2? How did we get the pi over 2 and 3 pi over 4?
I need in the middle of x over 2 because I'm studying x over 2, so I divided everything by 2.
Oh.
So dividing everything by 2 gave us pi over 2 here and 3 pi over 2, 2 pi over 4 over there. Exactly like the problem we talked about the graph. Cosine is between negative 1 and 1, and I multiplied everything by 3/4 because I needed in the middle 3/4 cosine. The same thing here. In the middle, I need x over 2. So knowing that x is in between pi and 3 pi over 5/2, which is the third quadrant. I divided all three sides by 2 to get in the middle x/2, so I know where the limits are for x/2. And they are between 5/2 and 3/4, which means second quadrant.
Were you willing to show
Yes.
how to find cosine x there using the triangle method?
Yeah, you have to present a triangle in the third quadrant in which you have so 10 negative 12 over 13, so 12 and 13, and you have to find this as being 5. So now sine will be 5 over 13 with minus in front.
I don't understand how you got those numbers.
I'm sorry?
I don't understand how you got those numbers.
Which numbers?
The 12, 13, and 5.
Once I'm told that sine is 12 over 13, it means the opposite has to be 12 and the hypotenuse has to be 13.
Oh, that was good.
By definition, yes, that was given to us. This is more complicated, in my opinion. You have to find your way, you have to find the sign. That is much easier. Just plug it in the identity. That's what I did. No, I don't have anything against this, but you have to remember that it's negative. Here you may remember that it's negative or you may not remember that it's negative, but here you have no choice because you have to put a minus in front. It's either plus or minus, you cannot put both. Again, that's fine, it's a perfect method. But the identity is much easier, in my opinion. But is it clear now? Caleb, is this okay? Do you understand that? But that's what I'm saying, it's a little bit more difficult because you have to clearly and correctly identify which one is what. Then since you're having sine, then this is 12 and this is 13. But if that is cosine, then this is 12 and this is 13. If you're given tangent, then this is 12 and that is 13. So you have to be careful. Over there, it's just an identity. You plug in a number and you take the square root. Do you understand where that is coming from, right? But this is the fundamental identity that we talked about, right? So we know that sine squared a plus cosine squared a is 1. So if I have this, I can determine that by moving it to the other side and taking the square root. If I'm given cosine, I can move sine to the other side, right? If I'm given sine. If I'm given cosine, to determine sine, then I move cosine to the other side and take the square root. Is that better? So this identity comes with 2 more. Sine squared a plus cosine squared a equals 1 comes with sine a equals plus or minus the square root of 1 minus cosine squared a, and cosine a equals plus or minus the square root of 1 minus sine squared a. These are together, and we should understand where they come from, right? Is that clear? Is that okay, everyone?
Yes.
So I have just 2 variables. If I solve for one, I get this. If I solve for that, I get this. All I have to do is move terms around and take the square root. Is that okay? So that's what I did, which I think it's much easier than picturing the triangle, and you have to make sure that you are in the correct quadrant. You have to make sure that you're finding these numbers correctly. So now your cosine will be this, which is -5, over this. But you cannot consider both negative. This cannot be a negative number. So you have to be careful. The answer is negative because this is negative, not because this is negative. So that's why I think that this is a little more difficult than simply using the identity. Is this better? Okay, so now we can go back and finally determine sine x over 2 and cosine x over 2. So for sine x over 2, we have the square root of 1 plus 5 over 13 divided by 2. And this will be the square root. 13 plus 5 is 18, divided by 26. And I will simplify a little bit. what can I simplify by? Just 2, and I get 9/13. And probably WebAssign will want you to write 3 over the square root of 13, which is 3 the square root of 13/13. And then cosine x/2 is the same thing, but 1 minus 5/13 divided by 2 from here. Minus in front, 1, it's plus, but this is negative 5/13. So from here we have 13 minus 8, which is 8, 13 minus 5, which is 8. So 8 divided by 26, or 4 divided by 13, or 2 divided by the square root of 13, or negative 2 the square root of 13/13. So once I have sine and cosine, all I care about now is finding tangent, and I don't need the formula once I have these two. So these two will go away and will be negative 3/2. So tangent a/2 will be negative 3/2. Any questions?